Unit 4 is biogeography, and biogeography asks the question, where is life found? We've already explored the theory of island biogeography, and so now we're going to look at the global distribution of life. Generally speaking, when we think of where life is found, we need to understand how climate works, because climate influences the distribution of life. Warmer climates with more precipitation typically have greater primary productivity. There's various adaptations of plants and animals that have to respond to different climatic conditions. Soils develop at different rates depending on climate. So climate is a big factor in determining where life is found. Climate is defined as a region's long-term atmospheric conditions, tens to thousands of years. So it's not the weather, it's not day-to-day, hour-to-hour, minute-to-minute, it's the long trends. It's trends in temperature, is it hot, is it cold, and trends in precipitation, is it dry, arid, or is it moist or humid? When we talk about temperature, we typically refer to three distinctive zones: tropical along the equator, temperate, our mid-latitudes, and polar. There are four major factors that we're going to explore that influence climate: latitude, altitude or elevation, bodies of water, planetary winds, and ocean currents. Today we're going to start with latitude. We know the Earth is a sphere. In fact, it's not a perfect sphere. We call it an oblate spheroid, which implies that it's a little bit pudgy, bulging at the equator, slightly flattened at the poles. Because of this shape, the Earth does not receive the same intensities of sunlight. In fact, most of the sunlight with the greatest intensity strikes in the equatorial region, and the angle of intensity decreases as you move poleward. Consequently, latitude influences both temperature and moisture. With more direct sunlight occurring along the equator, we have higher temperatures. And as you move poleward, generally speaking, temperatures decrease. The same can be said with moisture. Greater intensity of sunlight along the equator means more evaporation. The oceans cook from that sunlight, seeding the clouds. Furthermore, there's a lot of vegetation along the equator, tropical rainforests, and through transpiration, that moisture seeds the clouds as well. As you move north and south of the equator, moisture generally decreases. Of course, this factor is enhanced by seasonal variations. So what are the reasons for the seasons? This is an interesting one. I think a lot of people have misconceptions. There was a Harvard graduation where someone stood at the other end of the podium after students collected their diplomas, and they were asked the question, okay, great, well done for graduating from Harvard. Can you now tell me the reasons for the seasons? And about 95% of them botched the question. So many of the students in the recent grads said the reason for the seasons is that the Earth is closer to the sun during the summer and further from the sun during our winter. And that is actually not the case. Proximity to the sun has nothing to do with it. Rather, it has everything to do with Earth's tilt. So the Earth spins on its axis of rotation, and that spinning axis is not perpendicular to the orbit. Rather, it's tilted by 23.5 degrees. The Earth also revolves around the sun, making this a cyclical event, allowing for different intensities of sunlight to strike in the northern hemisphere along the equator or in the southern hemisphere, creating seasons that are flip-flopped for the north and the south. Finally, the Earth does not wobble back and forth. This allows the seasons to be predictable and orderly. So let's look at a diagram. Actually, let's look at an animation here real quick. So here's the Earth in its orbit, clearly not to scale, The Earth is spinning on its axis of rotation. You guys will notice that it is tilted by about 23 degrees from the perpendicular of its plane. I'm going to press play here. As it rotates, it's also going to revolve, meaning it's going to orbit around the sun. So right now we are heading to the first day of summer. Summer in the northern hemisphere. Notice in this particular position, the North Pole, the northern hemisphere in fact, is tilted towards the sun. That means the direct rays, because of the Earth's tilt at 23.5 degrees, is directly over the Tropic of Cancer. That's 23.5 degrees north. So we have summer in the northern hemisphere. The duration of insolation is influenced as well. If you notice, you go to the North Pole is rotating in and out of daylight. It's 24 hours of daylight. When I spent time in Alaska during the summer solstice, we played a softball game, and we could literally see the sun just about setting at midnight, but then it would just circle through the sky. So the duration of insolation is high at northern latitudes. Kids are allowed to stay out until all hours because 6 months later it'll be 24 hours of darkness. And that's exactly what's going on at the South Pole. 24 hours of darkness, rotating in and out of darkness. Now we're moving to autumn, or the vernal equinox. Let me bring it back here, guys. Sorry about that. This would be September 21st, the first day of autumn. Now you'll notice that neither the northern or the southern hemisphere is tilted towards the sun. Instead, the direct rays are right over the equator. We call this the equinox, which means equal day, equal night everywhere on planet Earth. 12-hour days, 12-hour nights. We continue in a counterclockwise motion around the sun. And we get to the first day of winter. December 21st is the first day of winter in the northern hemisphere. Notice that the North Pole is tilted away from the sun. The South Pole is tilted towards the sun. This means the direct rays are in the southern hemisphere. The perpendicular rays with the greatest intensity are over the Tropic of Capricorn. 24 hours of darkness at the North Pole, and now it's 24 hours of daylight at the South Pole. We continue counterclockwise. After winter comes spring, and this is the first day of the vernal equinox. Notice, just like the autumnal equinox, the direct rays are right over the equator. The Earth is cut in half with darkness and daylight. We have 12 hours of daylight and 12 hours of darkness. So to summarize, the intensity of insolation is greatest at the equator during both equinoxes. That's spring and fall, September and March. The Tropic of Cancer gets direct rays in the northern hemisphere summer, 23.5 degrees north. And during the northern hemisphere's winter, the Tropic of Capricorn receives direct rays. The duration of insolation also varies with latitude, as we saw. The North Pole during our summer has 24 hours of daylight. The South Pole has 24 hours of darkness. We can tell that this image of the Earth, a satellite image, represents the winter solstice. We can see 24 hours of darkness going on at the North Pole, while the South Pole would have 24 hours of daylight. That's it for now, guys. We'll see you for our next screencast.